Okay, so the next lesson of Chapter 7 deals with powers of 10 and scientific notation. We have seen both of these concepts many times before. So I'm going to just dive right into it. Evaluate each power of 10 means write out this thing as a number or a decimal. So there's a very, very, very easy trick for this. If the 10 has a positive exponent, we're going to write a 1 followed by the exponent number of zeros. If the 10 has a negative exponent, we're going to write a 1, but we're going to put the number of zeros before it, and between the first two zeros, we're going to put a decimal point. So let me show you how that works. 10 to the negative 3. That means I'm going to want to put 3 zeros before the 1. Because the 3 is negative, I want to put my zeros before the 1. So 3 zeros before a 1. And I want to put a decimal point in between the first two, so that it's 0.001. That's all there is to it. That is 10 to the negative third power. It is 1/1000th. 10 squared. 2 is a positive number, which means I'm going to put 2 zeros after 1. 10 squared is 100. 10 to the 0 power, this is a trick. Anything to the 0 power is 1. And 10 to the negative 5, again, that means I'm going to put 5 zeros before 1. So 1, 2, 3, 4, 5, and then my 1. Putting a decimal point in between the first two. So we have 0.00001. And that is 1/100,000th. That is 1/100,000th. Next set, write each number as a power of 10. Okay. Here we're just going to count up the number of zeros either before or after. Pardon me. Felt that coming. So what we do is we count up the number of zeros. We determine if they are before or after the 1, and that tells us if we're positive or negative. So our first example here is 10 million. There are 7 zeros. They come after the 1, so that's a positive exponent. So 10 million is 10 to the 7th power. In the next example, there are 3 zeros. They come before the 1, and there's that decimal point that I want to see between the first two. That means this is 10 to the negative 3 because of the 3 zeros. 10 by itself, well, there's 1 0, so that is 10 to the first power. And 0.00001, there are 5 zeros before the 1, so that is 10 to the negative 5th power. You do need to be careful with the negatives. Make sure that there is a 0.0 starting the expression. If it's just 0.001, you need to write down the 0 before the decimal point so you get the correct value for your exponent, 3 instead of 2. So up next, find the value of each expression. So 97.86 times 10 to the 6th power. Okay. So this is 97.86 times 1 million. 1 followed by 6 zeros. You've got choices. You can do this with a calculator. Or I'm hoping some of you are remembering, and this goes into scientific notation, which is what we're going to hit next, but multiplying by 10 to a power is a really sneaky way of just saying, move the decimal point. Here, because the power on 10 is a positive 6, it's saying grab that decimal point, move it right 6 places, and anywhere you make a hole, fill in zeros. So in the number they gave me, 97.86, I can move the decimal point 2 places to the right to get to the end of what they gave me. I'm supposed to move it 6 places, which means there's 4 more spots to go. That means I'd be filling in 4 zeros. Go back through and put down my commas, because that's a big number. Commas are helpful so I can know exactly what number you're telling me. 97,860,000 is that number. On the next guy, 19.5 times 10 to the negative 4th, the key feature that's different is the exponent is negative and a different number. The fact that it's a different number just means the decimal point will get moved 4 times instead of 6. The fact that it's negative says move the decimal point to the left. So I can move that decimal point back 2 places in the number they gave me. I can move it left so that it's now between the 1 and the 9, and then again so it's before the 1. But I have to move it 4 places, which means I have to have 2 more zeros in front of that. It's a good habit to put an extra 0 in front of the decimal point so the decimal point is highly visible. If I see a double 0 starting a number, the chances of me missing a decimal point are very slim. I realize many of you will type your answers. If you do, the chances of me missing a decimal point are pretty low. But if you're writing your work right now and taking a picture and uploading it, decimal points can be very difficult for me to see. So you need to make a point of putting that extra 0 in front. That'll help my eye, and you know I've got bad eyesight, that'll really help me see the, whoops, didn't need to do that. That'll help me see the first 0 and help me see the decimal point. So then we've got the vocabulary for scientific notation, which is a method of writing numbers that are very large or very small by writing them as a number multiplied with a power of 10. They look like a number times 10 to a power. The power has to be an integer, and the number has to be between 1 and 10. 1 is allowed, 10 is not. Single-digit number, and then you can have as many spots after the decimal point as you need in scientific notation. But you are only permitted to have one number to the left of the decimal point. So the other thing you'll be asked to do in this section is to translate between scientific notation and standard form, which is what your numbers always look like. So 5.91 times 10 to the 8th, we've already done 2 examples like this. Transferring to standard form is very easy. 10 to the 8th, it's a positive 8. That means move your decimal point 8 times to the right. You can move it 2 times in the number that you were given, 5.91, which means there are 6 more spots to go. So we have to give this thing 6 zeros. And I would ask that you go back and fill in commas, because it's a lot easier for me to tell that you got 591 million when there are 2 commas there versus 591,000,000. Last example, we've got 7,784,000,000. That is in standard form, so we're going to write it in scientific notation. So the key thing to realize here is that I've got to put my decimal point here. It's got to go between the 7s because I'm only allowed to have 1 digit to the left of it. Right now, the decimal point's hanging out on the end. It's invisible. Let me make that a little bit easier to see. We have to move that decimal point back. However many times it takes. If I'm counting correctly, that's 9 moves the decimal point to get it back to that giant gold spot I highlighted. So, if I put the decimal point between the two sevens, I'm going to have 7.784. I can stop there. Once there's only zeros remaining, I don't need to write them. How many times did I move the decimal point? 9. So it's going to be 10 to the 9th power. You may be asking, how do I know if that's a positive 9 or a negative 9? And that's pretty simple. If the number you were given in standard form is large, billions, millions, thousands, whatever, it's going to be a positive. If it is small, meaning it's a decimal, your exponent needs to be negative. Put more simply, if you have to move the decimal point left in order to get your leading number, your 7.784 in this case, then your exponent should be positive. If you would have to move it right, your exponent must be negative.